and welcome to session 3 of Unit 1. In this session, we'll be looking at the similarities and differences between nuclear and chemical reactions. By the end of this session, you should be able to state the differences between nuclear and chemical reactions, and you should also be able to state the similarities among nuclear and chemical reactions. Let us begin by looking at nuclear reactions. Nuclear reactions usually involve spontaneous disintegration of atoms of unstable nuclei, and this is what we refer to as radioactivity. In nuclear reactions, the electrons do not participate in the reaction. Instead, they stay in their orbitals while the protons and neutrons undergo changes. Nuclear reactions, we can see, also involve the decomposition of the nucleus and have nothing to do with the electrons. When the nucleus decomposes, it may change to another atom, and this happens by the loss or gain of neutrons or protons. It is very important to note that in nuclear reactions, the protons and the neutrons react inside the nucleus of the atom. Also, anytime nuclear reaction occurs, there is a high and a very high energy change that takes place. Nuclear reaction can be categorized into two forms. They are the nuclear fusion and nuclear fission. So, as we are saying, there are two types of nuclear reactions: nuclear fusion and nuclear fission. In nuclear fusion, two light nuclei combine to form a heavier nucleus, and large amount of energy is released in the process. In nuclear fission, a large unstable nucleus is split into two smaller stable nuclei, and energy is released. So, from the diagram below, when a neutron is used to bombard a nucleus, what happens is that the nucleus splits, where it can produce other neutrons and can also produce a fission product. We shouldn't forget that we say fission is the splitting of the larger nucleus to give smaller nucleus. So it can split to give a fission product, another neutron, so as many neutrons as possible and as many fission products. Now let us look at chemical reactions. In chemical reactions, electrons are shared, lost or gained in order to form new compounds. In this process, the nuclei just sit there and watch the show, passively sitting by and never changing their identities. So we can define chemical reaction to be the process of converting an element into a whole new element. Now, the elements at the beginning of the chemical reaction, we call them the reactants, and what is formed at the end of the reaction, which is the new formed component, we call it the product. For a chemical reaction to take place, there are certain factors that must be placed or must be involved for the chemical reaction to take place, and they include the presence of catalyst. Temperature could also have an effect on a chemical reaction. The solvent that is being used could also have an effect on a chemical reaction. And there are so many other factors too. These chemical reactions could go on very fast or could proceed slowly. We use the term rate of reaction to simply determine the speed of any chemical reaction. Chemical reactions can be represented using chemical equations. So let's consider the following reactions where reactants A and B are going into a product C and D. So you have reactants A and B going into the product C and D. Now the A, B, C, and D that are in smaller letter attached to the uppercase letter A, B, C, and D, they are the coefficients of the reactants, and we shall see the effects that they will have on the rate of the reaction. With the reaction that we have here, A plus B going to C and D, the speed at which the reaction is occurring, that's the rate of the reaction, can be written in terms of the reactants A and B, or can be written in terms of the products C and D, where the rate at which A and B are being consumed or they are diminishing should be equal to the rate at which C and D are being formed. Because the reactants are decreasing, they are being consumed to form the products in the reaction, we designate their consumption by a negative sign. So you can see a negative sign on 1 over A times change in A over change in time. And because the products are being formed, we designate that by a positive sign, which we don't normally write in writing equations. So now to show the rate of the reaction, then the ratio of A is diminishing should be equal to the rate at which B is diminishing, and that should be equal to the rate at which C is being formed and the rate at which D is being formed. Let us look at the comparison between chemical and nuclear reactions. So chemical reactions can be said to be the arrangement of the atoms or the elements to form new elements. And nuclear reaction involves the change in the nucleus of the atom, which is accompanied by the release of large amount of energy. Also, in chemical reactions, electrons are responsible for the reaction, but in the nuclear reactions, it's the nucleus, which is made up of protons and neutrons, that are responsible for the reaction. The chemical reactions also take place outside the nucleus, as we stated in our previous slides, but nuclear reactions involves the nucleus. It takes place inside the nucleus. Also, in chemical reactions, there is a loss, gain, or sharing of electrons, which results in the formation of new products. But in nuclear reactions, the nucleus decomposes to give a new product. Low energy change occurs in chemical reactions, but high energy changes occur in chemical reactions. In chemical reactions, the reactions are basically the same, but in nuclear reactions, the isotopes that are involved react differently. So two isotopes will react in distinct ways as compared to in chemical reactions, where when you have two or more isotopes, their reactions are basically the same. Also, the reactants and products have equal masses in chemical reactions, but in nuclear reactions, the masses of the reactants are different from the masses of their products that are formed. So, in summary, we can say that one of the main differences between nuclear reaction and chemical reactions is related to how reaction takes place in the atom. So, while nuclear reactions takes place in the atom's nucleus, chemical reactions takes place between the electrons. Let us look at the similarities between chemical and nuclear reactions. In chemical reactions, atoms are arranged by breaking and forming of chemical bonds, and this what results in the formation of new compounds. In nuclear reaction too, there is a conversion of an element to another one by the disintegration of its nucleus. In chemical reactions, only electrons in atomic or molecular orbitals are involved in the breaking and bond formation. Also, in the nuclear reactions, the protons, neutrons, electrons, and other elementary particles may all be involved. So they all involved electrons and the subatomic particles. Also, chemical reactions are accompanied by the release of energy, but the energies they release are smaller, and nuclear reactions are also accompanied by the release of energy, and they release large amounts of energy. Chemical reactions are influenced by temperature, pressure, concentration, and even catalyst. But the rate of reaction involving the nucleus, that nuclear reactions are not really affected by temperature, pressure, and catalyst. In this session, we looked at chemical reactions, where we said chemical reactions involve the conversion of one element to another, and we stated that there are certain factors such as temperature, pressure, and even catalysts that affect the rate of these chemical reactions. We looked at nuclear reactions, and we said it is the disintegration of atoms of unstable nuclei, which we refer to as radioactivity. We did comparisons between chemical and nuclear reaction. We realized that the main difference between chemical and nuclear reactions is that the chemical reactions involve the valence electrons of the atom, but the nuclear reactions involve the subatomic particles found within the nucleus of the atom, which are the protons and the neutrons. These are self-assessment questions to help you prepare for your quizzes.